What's the area of the toppled square? Let's look at the bottom triangle. There's a 90-degree angle on the bottom right, and we'll call this angle theta on the bottom left. Since all angles in a triangle add up to 180, the remaining angle is 180 minus 90 minus theta, which simplifies to 90 minus theta. Now, because this angle inside the square is 90 degrees and this angle is 90 minus theta, we know that this angle must be 180 minus 90 minus 90 minus theta, which simplifies to theta. Accordingly, we find that all of the angles in the middle triangle are congruent to the angles in the bottom triangle. We can repeat this process with the top triangle. Then, using the angle-angle-angle similarity theorem, we can prove that each of these three triangles are similar to one another. Since we know the areas of the squares, we can find their side lengths by computing the square root of their areas. The side length of the bottom square is the square root of 27, and the side length of the middle one is the square root of 12. With these two measurements in hand, we can get the lengths of both legs of the middle triangle. A simple application of Pythagorean theorem reveals that the length of its hypotenuse is the square root of 15. Since the triangles are similar, the ratio is the same between each of their corresponding sides. The length of the right leg of the bottom triangle is the square root of 27, which is in a ratio of 3 to 2 with the right leg of the middle one. We can use this ratio to find the hypotenuse of the bottom triangle. We can use the same logic to find the hypotenuse of the top triangle. Its sides are in a ratio of 1 to 2 with those of the middle triangle, so the length of the top triangle's hypotenuse is half that of the hypotenuse of the middle triangle. The side length of the toppled square is equal to the sum of the lengths of the three hypotenuses, or 3 times the square root of 15. We can square that number to get its area, which turns out to be 135.